There's a well-kept industry secret that shrouds UVs in mystery. And once you know it, you'll be able to see through the illusion and be well on your way to UV mastery. Welcome back to the Tech Art Simplified series. My name's Burke, and today I'm going to show you a new way to think about UVs that's going to open up the door to some really wild possibilities. The secret is that UV's natural state is not tiled. That's just a setting applied to your texture sample node. And if we turn it off, then the UV coordinates can be clearly seen for what they are, simply a window. And what's really happening is that our texture sample node is applying a grid over our texture. The grid ranges from 0 to 1 along the x and the y axis, starting at the top left corner and going to the bottom right. And the UVs, whose boundaries are represented by the values along the borders of our window, they tell the shader what section of the grid we want to access. And with tiling active, the shader just repeats the texture at every whole number. And since it's all just math, we can offset the location with addition, or we can scale it with multiplication. And if we split the coordinates, we can scale along a specific axis. It's important to remember here that you're not changing the texture. Its values are always going to be the same. You're just stretching and compressing the values in your window. And you've likely noticed that our scaling is only happening around the 0, 0 location on the texture. And for you mathematicians out there, it makes sense. 0 times 0 is always 0, and everything beyond that changes in value. And this brings me to the first advanced UV technique I'd like to show you. We can actually scale a texture from its center, and here's how. First, we'll subtract 0.5 from our x and our y. So when we scale, we're now scaling from the center of our window. The trick is to add back our 0.5 after the multiply. And now we've shifted our window back to the center of the texture, and when we multiply it, it scales around the texture's center. This technique is great for textures you want to scale dynamically in-game, but scaling from the corner would ruin the effect. And shifting the second addition value will allow you to scale from any point on the texture, which is helpful if you're using something like a sprite sheet. Pretty neat, but we're just scratching the surface. We've tried addition and multiplication, but what if we use a power operation? If you've seen the Tech Art Foundations video, you know that our power node is going to create an exponential shift from our 0 to 1 values. So if we run our y gradient through a power node, we get this cool warping effect where we can stretch our texture on the one end and compress it on the other. An effect that's really useful for waterfalls, where you want the water's built-up energy to stretch and relax as it reaches the base of the falls. Okay, we've run through our math operations. Now, how else can we affect the values on a grid? I know you've already been thinking it, you wizards, with another texture. Here I have a noise texture that we can apply over the top of our UV gradients. Black and white is mapped 0 to 1, which would push all the values positive. So to make the effect push and pull, I quickly remap the texture to negative and positive 1. Now when we apply it, the noise is warping our window to give us this trippy psychedelic effect. Again, remember, we're not changing the texture. All we're doing is manipulating the way we look up the data in our UV window. VFX artists use this technique and a time node to create smoke and fire effects. With this knowledge, you now have the key to a huge variety of unique UV effects, but this isn't the only way tech artists use UVs. Since UV coordinates are essentially just gradients, we can also apply them as masks. And if you've unwrapped our UVs like a tech artist, we have a perfect gradient mask for our mesh. Here we have our UVs being changed by a power node to act as a foam mask for our waterfall. And with our properly unwrapped circle, we have a foam mask that fades to the edges of the pool. But we can go even further with two helpful nodes. The first is the sine node. The sine node creates a smooth wave peaking at positive and negative 1 and resetting at 0 on every whole number. We can use this to create a mask that will isolate the specular reflections of the top of our waterfall. The repetition can be adjusted to keep the value from repeating over the mesh. But maybe you want the repetition, like here on the circular mesh that would isolate the foam at the center of our pool and at the very edges where the foam would lap the rocks along its border. So what if you want this repetition to mask evenly at the edges of your mesh? Well, you could do the math and line up your sine function, or you can use a cosine node and it does it for you. The cosine function starts at 1 and ends at 1, dipping down to negative 1 in the middle of the graph. This mask would be perfect for blending out the opacity at the edges of our waterfall. So there you have it, UV gradients as masks. This is just barely scratching the surface of the type of mask you can create using UV gradients. So I encourage you to get in there, play around, and see what happens. I hope you're inspired to test these nodes out yourself. If you make something you're proud of or have some questions, come join the Discord and hop in the conversation. Thanks for watching, and as always, work hard and play harder.